Okay, let's take a break from bit instructions because in the previous videos we covered almost all of the instructions, uh, what you see on here, right? Except for the these two. These two, as I mentioned, there's a special case of one shot, and also later on when we talk about the FVD and the ST programming language, we will also revisit those two instructions. They are very similar to that, right? So now let's start to talk about numbers, right? Push button and pilot lights, uh, they are not numbers, right? So and that uh, relate to a concept is called data type. So if you click here, there's a elementary data types. So that gave you some comparisons on here. So there's some uh, data type at the beginning. You can see the first one is bool. That's the one we use, right? So it can only have the range for this type of data can only have two options, either 0 or 1, and that's it. So that's enough for push buttons when the contact open or close, or the pilot lights turn on or turn off, right? So but there are lots of situations we need numbers. So if it's a one byte integer, so that has a wider range, right? So you can see it from there. So we'll look at that what's byte. All right. So then there also another type called int, represent integers. It has a wider range, and the most common one, mostly we'll talk about from this video, is DINT, double integer. So as you can see, it has a very big range from negative to more than 2 billion to positive 2 billions, right? So that's numbers in there. Um, with the numbers, we need to have a different type of instructions. So we're going to start to talk about them little by little, one by one, and not all of them, but some basic ones. The first one I want to talk about is the what we call move, because with the uh, button, the pilot light, you can energize it, de-energize it, or latch or unlatch, right? So that's normal operation. But with numbers, you cannot uh, use the latch unlatch and output energize to operate on that, right? You have to use different type of instructions. So we introduce the first one. It's underneath this category. It's called move logic instruction. There are lots of them. We'll talk about some of them, right? The first one, let's look at the MOVE, move, right? That's under the group of ladder logic, right? So with different type of programming languages, we'll talk about later, right? So let's focus on the first one, move. So move, very simple. The move instruction moves a copy of the source to the destination. The source remains unchanged, right? So that basically copy, right? You can say that, use that word, right? So when you look at the operands, right? The operands, that means the source and destination they just talk about, right? So one thing I want to let you pay attention, we talk about that the source and destination. Move, just move from source to destination. Then there's a column called format. So when we have on the instruction, I should show you on here, right? So you can see on here, move instruction, it has a source, has destination, right? Two of them. It's a different type of instruction. It has a box, right? Within the box, you need to specify the source and destination. The format with source, you can have two options, right? So one is called tag, the other one is called immediate. Immediate, that means the value, like for example all the numbers you type in, right? But with destination, it's only one tag on there. So I believe I have a better presentation to illustrate that. actually I got the picture from the previous old PDF manuals, right? So I think it's a better illustration than that. So again, let's look at the in the memory, right? So what we use for the PLC is belongs to this category, big family called Logic 5000. It is a 32-bit PLC controller. So that means the CPU of the PLC can process 32 bits, right? So match with that, your data, your memory can have 32 bits, right? So that you can see here, right? So basically that's the chart, right? Again, some of the basic terminology, bit, right? So single 1 bit, smallest unit like over here, right? So there's 32 bits in the CPU or in the memory around there, right? So remember we talk about bytes, right? Byte is the 8 bits. That's pretty standard. But when they start to talk about word, there are different numbers. That could be 16 bits because the history before, and then now we have a double word, right? 32 bits. So we have a double word, right? So 32 bits. So when you create a Boolean type of tag, you really only use the lowest single 1 bit because you only have 0 or 1, right? Binary numbers. All the other 31 bits are not used, right? So as you go from we call the signed integer, I think it's called signed integer, yeah, or single integer, I don't know, I'm not sure. And then you have a wider range like we look at out here. So the most common one is what we use as the double integer. It has the minus 4 billion, 2 billion and positive 2 billions, right? So the other thing that if you create the data type as a real, right, that can represent the decimal numbers on there, right? So that's keep going on. Look at here. So let's look at here. So again, when you create a tag, any name, right? Over here, I call that my boo, and then underneath the data type column, you choose BOL. So that's 1 bit. But when you create another tag, in this case I call my int1, you specify the data type as DINT. So if you do that, you will get 32 bits. So because when you open that, you will see start from the my int1.0 to .31. That match the previous slide I show you. There's 32 bits in it. You use all of them. So each single one is a bool, right? So there are 32 bool tags inside one of the double integer, right? So that's why the double integer tag can represent from minus 4 billion, 2 billion to positive 2 billions, right? Because it has so many bits. So on the right hand side you can see here, right? So when all the number is, all the bits are 0, yeah, the number is 0. But over here you can see with the bool you can only specify either 0 or 1. That's it, no other options. But with integer, for example, you can specify the value as a 5. Then how does the PLC represent the value of 5? It just turn on different bits, different bools. So you can see here, so the lowest one has weight of 1, that's weight of 2, weight of 4. The weights are different, and 8. Every time it doubles, right? Can't continue on there. So the PLC will just record, okay, I have a 1 on here, and also have a 4 here, right? So because this 2 has a 1 on it, so add them together, that represent value 5. All right, so that's basically the very basic concept from the integers. So then let's look at the move instruction. I think this is a better explanation here. So again, copy is from source to destination, right? And that's a box, right? I have a older picture, so before they only use MOV, but now they use MOVE. It's a newer version, all right? But that doesn't matter. Remember, I talked about the format, right? So it could be the tag, so that basically the name or immediate value. That means this, right? You could have different numbers, so that's belong to this category. So that guide you how do you set up the move instruction. Like for example, if you I gave you three examples out here, so you could use move value 5 to tag 1. That is good. Or you can use tag 1, whatever has within tag 1 you move to tag 2. That's also good, valid, but it cannot move a tag value to the destination 5. That they cannot change, right? The value cannot be changed. For example, the other thing is that if you move 3 to 5, it's also not valid, right? It will have error on there. So the other thing is that pay attention on the blue arrow that indicate the current value of the tag. So for example, you see here the blue arrow that indicate the tag value currently in the PLC. If it's online, that has the value of 0 or different values if that's the case. All right. So that's related to the move instruction. Uh, the other instruction. Oh, before I move on, I want to compare. Right, I want to compare with the what we learned before, the OTE, OTL, yeah. So those for bits, right? So those three set clear the value to the single bit. The move instruction copy to the 32-bit as a whole, right? We already explained that. So you need to have this distinction on there. They're different. So also one character with the move is that after that executed, the value stays at the destination, right? So you will see here. So if the button press, the Boolean tag is on. And also it has a parallel, right? It also move the value 1 into there. But when the button become open, right, the boot will be de-energized. That's what OTE does. But you will see the value on here, the uh, it will stay there, doesn't move, right? So let's do a demo here. Let me see here. So right now, if you look at on the right hand, you can see right now I'm running 0, right? 0 running on the sandbox. Sandbox is here. That's what this one is running. So I have a PB energized PL, and also if you look at DINT underscore 1, that's the double integer tag, right? The blue arrow indicate right now the current value on that is 0. So if I press button close, and then PL energize, and also this move instruction will change the value of DIN underscore 1 from 0 to 1. That's what you see. You can also see on here with the watch window on here, right? So let me get this on here. So when I press and hold the button, right? So you can see pilot light on, and also the DIN underscore 1 change to 1, right? And from the watch window, you can see they all change to 1. Then when I release the button, you can see the PB change to 0, PL change to 0, right? So they all change back to 0. That makes sense. You understand that. But you can see the DIN underscore 1, that the value stays here. You can see before was 0, and now it's 1. So that's what I mean. So based on this, you can see that it's similar to OTL, right? It's different from OTE, but similar to OTL, right? But it's different. OTL, remember I mentioned that it also keep the value after you have the power loss. When you turn back on, that is protected by the battery. But the double integer doesn't have this feature, right? So the double integer will be reset to 0 once you have power off, right? So they all related, but they all have some difference between that, right? So that's keep looking at. I also mentioned Mu can potentially have the double coil syndrome, right? So that's one thing I want to see on here. If, for example, we Control C, Control V, and if we use a different one, SS, and move to here, I want to show you the double coil. Actually, let me see. Let's keep that. Let's keep that. Yeah, let's keep the. If I move value 2 to here, so let me finalize. Alright, so we don't need the watch window anymore, so we can part here. So let's look at. So now you can see here. So we use two separate runs, energize PL, and also move different value to double integer, right? Double integer 1. So for example, if we right click toggle, and yeah, so you can see here the PL didn't energize, right? If you look at here, the PL didn't energize, right? You can see that, right? So that you understand, that's because the double coil, because you can see, on here this energized PL, but only at this run number 1, but at run number 2, because this SS is open, that has logic false, that de-energized PL. So that's why you don't see the light turn on, right? But here, this run, it will execute this move value 1 into the DINT 1, right? So if I right click the here SS, I toggle on here, right? When I toggle on here, you can see, yeah, you can see here PL turn on, right? So that makes sense, right? Because both energize it. So that right now, even though before I had a double coil syndrome override, but this time it works. It turns on, right? Also, I want you to see here, right? So you can see on this, it has value 2 override to the destination. Even though over here is still running move 1 into there, but it will be overwritten by 2 on here, because that's two separate runs, right? The later one always override the previous one, right? So that's what I mean by the double coil, right? So be aware of that, because you could have different values into the destination, right? So that will make change on that. Okay, so then the other instruction I want to talk about with numbers is the compare. Let's look at here. Instruction set and comparison. Compare instruction, right? So when you compare with ladder, right? Again, with ladder, you can make sure if they are equal, greater or equal, greater than, less than, and equal. So those comparisons, right? So you can look at on the description here. So that's the regular. There are also other functions. We don't have to talk about all of them, but you know the basic one, right? For example, if you want to test whether two values are equal, right, you would use EQ. So that's the instruction you should use. And I believe I mentioned here some special. Yeah. So with the comparison, of course, you either get true or false, depends on the value. And then I emphasize on here, it's not a output instruction. That means it cannot be the last instruction on the run. Actually, it is similar. It is in a similar situation as the exam on, exam off, or XIC, XIO. I can show you on that by one example. So what we want to work on with the toggle switch is based on the previous example called the large new tag. So if you remember this one, right? So let me bring the interface, right? So I want to use, I need to change this large new tag. All right. So when I change this large new tag, you can see here that the method value changed to 3. That calls the 03 large new tag, which is this one, 3. Right. So you can see here, button released, light is off. Then when we press, it's on, release, stay on, press again, off, stays off, right? So this is the previous solution. So if we look at here, this is all Boolean tag instructions. We can sort to use a double integer tag. Instead of on, you can see on is a bool tag, right? But now we can use a double integer tag to replace that. So of course, with the double integer tag, we have to change instructions, right? Before we have a large, unlarge, exam on, but now we need to use double integer instruction, use move to replace those two, and then exam on can be replaced by compare. So let me move to the sequence bit. Yeah. So int, I call int returnative. Returnative, that means the stays, right? The value stay. So that's the part I mentioned on the example. You can see right now value is 7. It's called 07 int returnative, and that is here. All right. So take a look of these two solutions. All right. Let's just try if that work or not. Right. On, stay, off, stay, on, stay, off, stay. Right. It works. And then let's look at the two different solutions. They almost identical. Right. Push button, one shot. Push button, one shot. If PL off, before we latch the on, but now I create a double integer tag called on underscore int. I just want to realize this is also come from here, but it is a double integer, right? So because it's large, we want to move 1 into the tag. Whenever you need to unlatch it, you basically move 0 to there, right? When you use exam on xic to check the tag value, over here you're actually doing the equivalent of equals, right? You check the value if it's equals 1. If it's true, you turn on the PL. If it's a false, you turn it off, right? So that's same thing. That's the same operation as this one, exactly same as this, right? It's just we change the representation, right? We use different tag and also instruction now as practice. So now let me do a final demo, then we finish this video, right? When I press and hold, that's what you see. You move value 1 into the on underscore int, and because of that, pilot light turn on, right? And after I release, because the value stays there, right? Returnative, right? The value is there. Even though the button is released, it stays there, and that keep the pilot light on, right? And then if I press second time, that will clear back to 0, and when I release, it stays to 0, and this will get logic false. Logic false will turn off the PL. That's why you see the result on here. All right.